we'll see each normal form in detail with an example. Okay. Now, first normal form. A relation is in first normal form if it contains an atomic value. So, as already said, every tuple in a relational table should have an atomic value. So, no comma separated value should be there. Now, say for example, a relational table contains these three attributes. Student table has attribute first name, last name and knowledge. So, first name and last name we supply names for the student. Then knowledge. We are trying to define different types of knowledgeable skills for a particular student. So, for instance, we say Java, C++ and PHP for one particular student, and PHP and Java for another student, and C++, Java. So here we have given data that is comma separated values in a single tuple. So this should not be there. So this particular relational table does not satisfy what is called first normal form. So then what to do? Now we are trying to separate data. See how we have separated data. See, for Thomas, first name Thomas, knowledge is C++. Again Thomas, knowledge is PHP. Thomas, again knowledge is Java. So this is how we are trying to supply atomic values for a particular attribute. Okay. So this is what first normal form deals about. Now, moving on to second normal form. A relation will be in second normal form if it is already in first normal form, and as said earlier, all non-key attributes in the relational table should be fully dependent on what is called key attribute. Okay, right. We'll see an example and understand what is it. See, we have a table like this. That is employee ID, first name, last name, sales office and office number. So now employee ID, as underlined here, it is understood that employee ID stands for the primary key attribute. Now this employee ID is the key attribute, and all the rest, that is first, last, sales office and office number, all these are non-key attributes, right? Now this first name and last name definitely rely on what is called the primary key. Okay, so if it is primary key 1003, it is understood that Mary Smith is that particular employee. Now, what about the sales office and office number? Sales office and office number, both these attributes, again non-key attributes, have nothing to do with directly with primary key, that is employee ID. So whoever is the employee, for every employee the sales office will be the same and the office number is going to be the same. So that need not be kept in this particular table. If kept like that, what will happen? We will have a redundant data. That is insertion anomaly, duplication of records will be there. So what should we do? We are trying to split the table into two. That is, we split table 1 and table 2. Table 1 is split like this. Employee ID, first name and last name. Table 2, again we split it as employee ID, sales office and office number. So now we try to split tables, right? We try to split tables. Why do we split? To satisfy what is called second normal form. Now we move on to third normal form. Now what is third normal form talking about? Already, as we said, a relation will be in third normal form if it is already in second normal form and no transitive dependencies exist. Now we will try understanding what is transitive dependency and how to avoid this transitive dependency. Now look at this table. We have a table with customer ID, customer name, customer city and population. So customer ID, as already said, it is the primary key, and customer name, customer city and population, all these are non-key attributes. The thing is that every non-key attribute should be fully dependent on key attribute. This is dealt with second normal form, right? Now in the third normal form, as seen here, we have two different types of dependencies. That is customer ID directly related with customer name and customer city, and customer city is directly related with population and not with customer ID and customer name. So city and population go hand in hand, that is they have direct relationship, but any customer can be in any city and that city may have any number of population. So this is how we try finding out how transitive dependencies exist in a table, right? So to avoid this transitive dependencies, now what we have to do, we are trying to split the table into two, right? Now normalization, what are all the effects of normalization? Disadvantages and advantage we'll see. Normalization helps to minimize data redundancy. As already said, duplication of records will be avoided. Then greater overall database organization can be done. So when we deal with huge amount of database, that is number of relational table taken into existence, when we deal with so many number of databases, the organization of all these will be smoothly done when we try applying all these normalization techniques on the table, right? Much more flexible database design. So this normalization gives us a flexible database design. Now, enforces the concept of relational integrity. So as already said, it is a relational table we are talking about. So while talking about relational tables, we will have to integrate all different tables and retrieve data from it. So doing that will be flexible only using these normalization techniques on the particular relational tables. Now we will see some of the disadvantages of normalization. The database cannot be started building before knowing what the user needs. So once we are thorough of the end user and his requirements, only then we can sit creating a database, relational database, and apply all these normalization. So then and there we cannot insert everything, because again if we will find all these anomalies getting inside. So it is one major disadvantage is that the end user requirement must be known at the first case. Then the performance degrades when normalizing the relation to higher normal forms, that is fourth normal form, fifth normal form. When we go on implementing different normal forms onto the particular database relational tables, it gets harder, right? Now it is very time consuming, so it takes so much of manpower, work hours to implement this normalization on a relational table. Careless decomposition of relational tables may lead to bad database design, leading to serious problems. Now when we try implementing all normal forms one by one, we will try to reduce the table into 2 or 3 and more. So when we try reducing the tables, introduction of foreign key for all the tables to retrieve the data, all these becomes very hectic. So these are some of the disadvantages of the normalization. Hope you have enjoyed listening to this PPT that is about normalization and its techniques. Thank you, one and all.